There you go. Okay. So I think the file I've uploaded is the wrong one. Let me try uploading the right file again. There's an additional file I want to upload, not the one called questions, but I want to upload a STATA file. Sorry, questions about STATA. Let me just upload that. Okay, it's not available. We'll just do it without that. Okay, so let's go back and download the dataset called knowledge. If you've downloaded that, please open it up inside STATA. So okay. Has everyone got the data set loaded onto their computer? Anyone not been able to do it so far?
Sorry, was that the Norwich one, did you say? The Norwich 2008?
Yes, it's called knowledge. That's right.
Cool. Yeah.
Okay. Okay. Now I should be able to download it, upload here another file as well that I want you to look at. I found the file. Sorry, I was having some trouble with it. So let me upload another file as well. Okay, so the second file I want you to download is this one called STATA questions. It's a Word document, and it just says computer test 2011. It's an old test. Can you please download this onto your computer as well? If you do, you'll see some questions given over here about this data set. So we're going to go through this as a practice exercise. Obviously, we don't have tests this year. We've done away with those, but this test can still be useful to see how to use data in real time. So again, the name of the file that I asked you to download is called STATA questions. Has everyone got a copy of it? Those of you who've gotten a copy of the data set and the question, please write yes. Okay, great. I'll wait another minute or so to have more people obtain the two things. That way, nobody will be left behind, or not that many people will be left behind. So for those who've joined late, I'll just repeat that in the usual location on the folder for STATA and instructions. Right at the bottom, you will see three. One is called Norwich 2008, which is a data set, and another one called STATA questions. Those are the two files that I want you to download. One is a Word document, open on the right over here. And on the left side, I've already downloaded the data set called Norwich 2008 and loaded it inside of STATA. Okay. Now, this data set essentially has 4 variables in it, as you can see from the describe or on these questions as well. These 4 variables are called property, price, type, and beds. And we're going to try and answer some of the questions that are posed over here. The only one that we will potentially have a slightly harder time in answering is the last one, because that one you really can do only if you've been doing the theory side of the material as well. And I don't know how many of you have watched the videos all the way through yet. So the last one you may not be able to do today, but I'll show you how I would do it. And then once you watch the video for the theory side, which does hypothesis testing, you can look at it over there as well. After that, I mean. Okay. So with that much in there, let me now just do one other thing. Okay. Okay, so let's start with the thing. How many properties are in the sample? Anybody want to take a guess on how we should find that information or where it is already located? You can probably see it on the screen. If you type describe, as I've done, it tells you right there how many observations are there, right? So the answer to this first question would be just 450, right from here. You see it? Okay. Next, if we have this, good, great. What proportion of properties have no bedrooms? How should we answer this question? Write out a command that you could use to answer the first question. List if beds 0. Let's try it. Will that work? List if beds equal to 0. Okay. So now the question was, what proportion of properties have no bedroom? So how would we do it? We'll count how many rows there are over here and then divide it by 450 and then report it over here. So that would be 1, 2, 3, 4, 5, 10, 15, 20, 21. So it would be 21 divided by 450, 0.046. Okay. Any other way that we could do it? Any other way we could get this 4.6%? Any other suggestions? How about tab beds? How many properties have 0 beds? 4.6%. Easier to do it this way, right? Use the tab command. So what Althea suggested works, but it's difficult to work with that command because you have to count the rows yourself and then manually, after counting those rows, divide by 450 the total number of observations, get this number, convert it into percentage. Here you're getting the answer directly. And this can be a little bit more difficult if there were lots and lots of rows. Supposing instead of 400, instead of 21, if it was supposing 210, then you'd be scrolling for quite a while, counting the number of rows, and you could easily make an error in the count of your rows, how many rows there were. Okay. Find the mean, median, variance, and standard deviation of the property. So let's do that. The hint is also given. You just use the word sum and price with the option detail. Okay. From here we can see the mean is 170.39. Standard deviation is 64.23. Hence variance would be the square. Minimum and maximum are also listed. The smallest is 49.7008. Largest, which is the maximum, is 423.473. And the median is 165.85. So you should be able to fill this entire area out by just typing in these values. Anyone confused about it? So here it would be 450. This would be, what proportion is 4.67. Mean would be 170.39. Median is 165. $165.8541. Standard deviation is 64.23. Maximum is 423.47. Minimum is 49.70. And variance is the square of 64 point whatever, so that comes out to be square it, that becomes 4126. You can type that here. Okay. Any questions so far? Okay. Which of the properties was traded for the highest price? Give the property number, describe the property. How would you do this question? How would you do this answer? Any guesses? You could try using the command that Althea suggested for one of the earlier ones, the list command, list with an if condition. What would that be? If you have a guess, please type it out in the comments. Any guesses? Please try a command that you think might give you the information for the property with the highest price. List if price greater than 350. Okay, you can do that. That will list all the prices above 350. So as a guess of the high price, well, we know what the highest price is. Look, we've just answered it here, 423.47, right? Yeah, so list, exactly. List if price greater than that with a lowercase list. So list if price greater than 423. And now it's just listing property number 389 which had a price of 423.4732, which is this one. The one that we had was the maximum one. It is a type 4 property with 5 bedrooms in it. What is the type? Type is 1 is a flat, 2 is a terraced, 3 is a semi-detached, 4 is if it's a detached. So you could describe this property as the one that was traded with the highest price of 423.47 is a detached house with 5 bedrooms. Okay. Property number 389, type 4 detached with 5 bedrooms. So as simple as that. Okay, obtain a histogram of the property and describe its main features. For example, is there only one mode? Where is the mode? Is the distribution symmetric? So what you need to do here is to answer this type of a question is basically first generate a histogram, and after you've generated the histogram, just describe roughly whether it's 2 peaks, 1 peak, symmetric, right skewed, left skewed, whatever. So let's first generate the command hist price. So that's the graph I get. You should get the same. And looking at it, one can say, well, it's got a right skew. It's got a modal value, single modal value somewhere in, looks like eyeballing it, because they're asking you to do is eyeball somewhere around midpoint of 100 and 150. So let's say 150. Sorry, midpoint of 100 and 200, so around 150. And that's it. So you could describe it as right skew, one mode, which is set around 150. Yeah, there you go. Next, find the mean price for flats, terrace, semi-detached, and detached prices separately. So I'm going to not do this. I'll ask you to do it. I'll wait a few minutes. Then I can show you how I would do it. So please go ahead and figure out the answer to part F. Write it out on, well, you have the Word document, fill in the 4 blanks. And once you've done that, then type in the word done in the comments section. And then I'll describe to you what I got. Okay? If it takes you more than 2-3 minutes to figure out and you're hopelessly lost, instead of typing done, just write lost. So I'll know that you need help with it and I'll start earlier. So either type done or type lost. Has anyone done it so far? Done. One person, great. Two people done. Okay. For those who are still struggling, the command is given over here, how to do it. Tab beds type some price. So remember, if you just do tab beds, it tells you houses with 0 beds, 1 bed, 2 bed, 3, 4, 5, right? And if you do tab type, it tells you houses of type 1, type 2, type 3, type 4. Now, what we can do over here is just do tab beds type, and sorry, what was being asked? Where was I? I've lost it. Oh, this one, sorry. That one, this one. So tab type price, and now some price. If we combine tab type with the summary statistic command, as I showed you yesterday, sum price, you will get the mean value and the standard deviation and the number of observations for the variable called price by the groups 1, 2, 3, 4. So now over here, if you want to type the value of flats, flats was given as type being 1. So for flats, it would be 134.28. And similarly for the other ones, you would have similar values that you can read off from this table. Okay? So flats is 134.28. Terraced is 148.82. Semi-detached is 175.26 or 27. And then detached is 225.72. Okay. Anyone still confused how I got these or why I'm reading these numbers the way they are? Should I move on? Okay. How many 4-bedroom detached houses are in the sample and what is, no, but could you remind me how to label them as flat, terraced, rather than 1, 2, again, please? Okay. That's a good question. Might be worthwhile doing it. I'll open up that slide that shows you that to do the value labels, you have to do 2 types of things. First, you have to define the value label, and then you have to apply it. So I'll bring up the commands for it, and then we'll do it from there. Give me 1 minute to bring up that command. Okay. Okay. So when we wanted to do the male 0 and 1 as male and female, we first defined it and then we labeled it. So when we define it, we have to create a name for it. And this name we then apply to the variable that we wanted to use. So here, what we could do is, following the same methodology, we could say we would first define it. So label, define, and here we would give it a name. So let's say HT or house type, HT for house type, or H label. Let's call it type label. And here we have 1, which is given to be flat. Flat. 2 is terraced. 3 is semi-detached, and 4 is detached. Okay. So here what we're doing is we're first defining it using the command label define, then giving it a name for this thing. It could have been any name you wanted. You could have called it XYZ. I'm just calling it type label. And then the values that it has, 1, 2, 3, 4, and what meanings to apply to each of those. So that's been defined. Now, if I do the same command as before, it will still show the same words, numbers 1, 2, 3, 4, because they have not yet been applied. So now we need to do the second part of it, which is we apply it to the variable called type. So we would type type label values, and we would do type and then the name that we have given it. So it is type label. Okay. Now once I've done that, if I issue the same command tab type some price, I get the same output looking a little bit better. Flat, terrace, semi-detached, and detached. Okay, that helps. All right, so let's move on to the next question. How many 4-bedroom houses are in the sample, and what is the mean price of them? Again, there's a command given over here. Tab beds type this, so type it over and you'll get the values. So tab, now we're doing 2 types, tab beds type some price. So you can see that those labels are showing up here as well. They are not showing up here because we haven't assigned labels to the number of houses. It doesn't, to the number of bedrooms. It doesn't make sense to attach any labels to them because those are the actual values. And now the question is, how many 4-bedroom detached houses are in the sample? And what is the mean price of these? So how many detached 4-bedroom detached houses? So you would go to the 4-bedroom and the detached. What's the answer over here? 230.4 is the mean price. That's right. And what is the number of houses? Because it's asking 2 things. What is the number and what is the mean value? Mean value is 230.40 and the number of houses is 53. Correct. That's it. That's all you need to do. Okay, the last one I'm going to do, but it may not make too much sense. right now. To some of you, because if you've not read the slides, the hypothesis testing will not have much meaning, but for what it's worth, the command could be done by just typing CI, which will construct the confidence interval in STATA for the variable called price. Oh, the command has changed to sound. CI, you must specify CII, I think. One second. Oh, CI. Yes. The command is CI means var list. Yeah. So to answer this question, denote as mu the population mean of properties in Norwich. Find a 95% confidence interval. If you were doing it by hand, you would use the methods that are given in the slides. And if you do it that way, it should come back and give you exactly the same answer as STATA is giving you over here, which is given by the 95% confidence interval to be 164 to 176. Then the mean price of properties in Norwich in 2000 was 180,000. Is there evidence in the sample that the prices have fallen since 2007? To answer this, conduct a t-test with null given as 180 and the alternative given as mu is less than 180. Quote the p-value, illustrate the t-statistic and p-value on the diagram and the t-distribution, and interpret the results. So one way to do it would be to type, again, to do it the way it's explained in the slides. But if you are doing it on computer, you can use the command t-test I. T-test I. And then you would give the, let me show you the help part of it first. T-test, help t-test I. If you do that, I means the immediate version that you're going to provide the values. So when you do the t-test I, you first provide the number of observations, then the mean value, standard deviation 1, observations in the second, mean value of 2, and second observation group. So here, what we want to do using this particular syntax, we want to type t-test I 450 170.391 64.23987 180. Okay, where are these values coming from? Let's think about it for a second. T-test I, number of observations 450. That we already knew is the sample size. Then after that, I'm providing the mean value that's observed in the data. So that's 170.391. Then I'm providing, after that, the screen has zoomed for me. Anyone else? Okay. Let me write it in Microsoft Word, this command, and I'll make it zoomed over there. Sorry if you can't see. Let me open a file. Okay, this is what I've written. T-test I, 50, then the number, the mean value, then 64.23987, and then 180. Okay. And where are these coming from? If you again look at type help, T-test I, on your own screen, you will see the immediate version of it, how to use this. It says, type the command t-test, then provide the number of observations, then the mean value, standard deviation, and then the value that you're trying to test it against. So this is standard error, but the standard deviation, if you remember, was given by earlier. We had computed it up here. So let's just type it again, SUMM price. So you can see that the standard deviation is 64, mean is 170, and number of observations is 450. So based on these, I'm now going to construct a hypothesis. I'm going to do a confidence interval and a t-test, sorry. And like I said, that the command for that is you give the mean value, sorry, number of observations, the mean value, standard deviation, and the null that is given. Another way to think of it is write it as t test I obs mean, observed mean, standard deviation, and then null value, null under null hypothesis value. Okay. So these are the 4 things that you need to list. And if I list those, it will perform the t-test point, and it comes back with this output. The t statistic is minus 3.1731, and the p-value, associated p-value with it is listed over here. For the alternative test is 0.008. Why this one? Because the alternative we were given in the question was it is less than 180. So for the alternative that the mean is less than 180, the associated p-value is 0.008. So these are the 2 numbers that you would have to report over here. So you would put this here. Let's make it bigger. And then t-stat is essentially minus 3.17, and the p-value is 0.008. And you would reject the null.
Sorry, it's frozen again for me.
It's frozen for you, okay. It might clear up in a few seconds because I can see my cursor moving. I leave it on screen and see what happens. Reject the null. Write it out on the chat if that helps. So I'm writing basically that the t-stat is equal to minus 3.17. P-value is 0.0008, and the null has to be rejected. So reject the null hypothesis. Okay. And the command that I had issued, if you want me to write that in the chat box as well, this was the command that was given. Any other questions about this exercise? Am I still coming in as frozen, or is it back to normal? Can you see it? James, is it still frozen? Okay.
So I left the session and then came back in, and now I don't see anything really.
I don't know what to say. I'm sorry about that. Let me see if you're saying you cannot see the screen yet. Let me stop sharing the screen and try sharing it again. I'm going to try and see if it lets me share it again. Okay, I've turned off the camera. Let's see if that helps. Can you see the screen now? Yes, okay. All right, sorry about that, guys. I don't know what's going on with the internet connection. Anyway, so the values are written over there. And the command I've put already in there, but I can again show you what command I was trying to show you. This is the command you would need to type. It's in the format t-test, number of observations, mean value, standard deviation, and the null value. So those are the four listed over here. Number of observations 450. The mean was observed to be 170.391 in the data set. Standard deviation was 64.23987 in our data set. And the null value that the test is asking for is to test it against 180. So we're doing a one-tailed test, the left tail test. And for that, our t-test is minus 3.173 and p-value is 0.008, and we reject the null. Okay. Again, go back, look at the slides. The slides explain a little bit more in terms of how we do the testing, how we do it using a calculator, and then over here, what you're learning is how to do the same thing using a computer. The difference between the two is the reason why it's important to read the slides and understand is that even though you're not going to be using a calculator for practical actual work, but to understand how to do the hypothesis testing, what it is that you're testing, all that is explained in those slides and the associated videos. So it's important that you engage with those. Any other questions about this stuff? Okay. Well, today's session can be short. We can end at 3 o'clock or even sooner if need be. This is all I really wanted to share with you today for the STATA. So this takes us to the last exercise on STATA. And if you have any questions about it, I'd be happy to try and answer them. I can stay logged on for a bit. And if not, then we can start logging off slowly. But whoever wants to leave can leave also. Anyone with any questions? Anyone? Anyone? Going once, going twice. Any other questions from any of the other days? Doesn't have to be just about this. Could be anything you want to ask me around these data-related issues. Could you please explain the null value means? By null value, I mean the question said that test it against a null. So the null is that you state in these hypothesis testing. So whenever you are doing a problem like this, somebody has to say, okay, I think that the true value. So the issue arises as follows. You're observing something like in a data set an average value of 100 or 200 or 300. Some value you observe. In our case, we observe an average value for the price to be 170. And remember, our data is a random draw from the underlying population. So while our sample average is 170, remember that the sample average itself is a random variable, and it's trying to mimic the population value. So somebody else comes around and says, no, I think the true value is 180. And you say, well, if it's 180, how should I test that I would have observed something like 170 if the true value was 180? So for that, you construct a null hypothesis. The null hypothesis becomes, supposing the true value is whatever is stated, so mu equal to 180, that becomes the null value, or what is called the null hypothesis value. And then you test that against the alternative that is given, which is that no, it is something less than 180. That's where this null term is coming from. And that's what we were doing in this test. Does that answer your question, Gianbo? Gianbo, does that answer your question? Okay. Okay, then I think we can all log off if there aren't any other questions. And thank you very much for attending these STATA sessions. It was fun teaching those. Hopefully I'll see you in person around campus, and not just be meeting over the computers. You're here for the whole of the rest of the year. I'm also around. So when and wherever necessary, stop by if you need some help, or just stop by to say hello, because it's nice to see people in real life as well, and rather than just meeting for a class online. Okay, thank you. Bye-bye.